Okay, let's get started. Okay, good morning, good evening, good afternoon, wherever you are. This is the ChaosMesh community meeting for June, and it's been a while because we skipped the meeting for May because of the KubeCon. And we're glad to see some new friends and many other old friends here. Before we get started, a couple of things. Firstly, when the speaker is presenting, and for others, you might be muting your phones to avoid some unnecessary noise. And also, this meeting is recorded and will be uploaded to the YouTube on the CNCF channel on the CNCF account. Okay, let's get started with the first section. It's always the introduction part. Oh, I forgot to introduce myself. I'm Kelvin, and I'm one of the ChaosMesh maintainers focusing on content and documentation. And normally we would have the new faces introduce themselves here. I think I will just skip Vince because we will introduce Vince in his sharing. And now let's start it from some strange friends here. Firstly, we have Suhei Kawamura. I think you're from Japan. Would you like to introduce yourself and say hi?
Hi.
Hi, good to have you here. Maybe a brief introduction to yourself.
Hi, I'm working in Oracle Japan, and I introduced the Kubernetes and ChaosMesh and so on.
Okay, so you're already using ChaosMesh, right?
Okay.
Great. Yeah, yeah. Let's. I will get to know you better soon. But for now, let's just go to the next. So we have Naveen Kumar. Hi, Naveen.
Yeah, hi, Calvin. How are you?
I'm good. Thank you. Would you want to say hi to the community?
Hi, guys.
And,
thanks. Yeah, sure. Yeah, hi, everyone. I'm Naveen Kumar. I'm a tech blogger. I'm working as a performance testing and chaos engineering from past many years. Yeah, great to be here. Thank you.
Thank you. I'm looking forward to your new posts. Maybe one about ChaosMesh, probably.
Yes, yeah, sure. Yeah, I'm working on that. Yes, thank you.
Great to know that. Thank you. And then we have Neil here. Hey, Neil, good to have you here. Would you please introduce yourself? Hello, Neil.
It's like Neil left.
Okay, it's awkward. I also see Xianglin Gao here. Actually, I will also introduce Xianglin later in our community sharing. But Xianglin, would you please introduce yourself and say hi to the folks here? Hi, Xianglin.
Hey, hello.
Hi.
Can you hear me?
Yes.
Oh, okay. Let me introduce myself. I'm an engineer at Tencent, and I'm focused on the choice engineering for now. And I have great interest in the kernel smash, and I'd like to put my effort to make the project to be better and better. And I hope we can meet someday, right? And
Yeah,
we
sure.
can talk. Okay, and we can meet up. Maybe we can have a meet up and to see each other and to talk about the ideas. Right? Okay. I'm finished.
Yeah. Great. Thank you, Xiangling. Actually,
Thank you.
since you already introduced yourself in such a detailed way, I kind of have this. I will have this spoiler alert now. So Xiangling is actually newly promoted to a chaos mesh committer. So congratulations to Xiangling. And we thank him for
all of you.
Yeah, we really thank him for the effort and contributions he's made to Chaos Mesh. Yeah. Okay. Let's. Yeah. That's all for the introduction, and we're glad to see so many new friends here. Now let's really kick this meeting off with the first section of the community sharing. This one is from Vince Huang from K6, and he will introduce. For those who do not know, K6, it's a open source load testing platform for engineers and QA person to do load testing with their like APIs, microservices, etc. Okay, that's enough from me here. Firstly, let's welcome Vince to start his sharing. Vince, it's all yours.
Yes. Okay, great. Thank you. I'm going to.
Okay, you want to start? Okay. You want to? Yes. Let me stop my sharing here.
Originally ready, and then I had to make a change. Let's just share. Everyone see that okay?
Yes.
So, thank you everyone and team for letting me present here today. I was here to. I originally had an interest. My name is Vince Huang. I've been breaking things.
Sorry, maybe you have something wrong with your voice. Your microphone.
Let's move the mic a little bit. Can you hear me? Okay. Can you hear me better now?
Oh,
yes.
Is that better? Okay. Yeah, thank you for letting me present today. My name is Vince Huang. I've been effectively breaking things for the past 10 or 15 years, doing various things in operations to SRE to product management and things of that sort. So I am I'm honored to be able to present K6 to you in terms of, there's a lot of overlap between the chaos engineering mindset and the performance and load testing world. And so I'm hoping that maybe an introduction with K6 and load testing in general can kind of help with uncovering some of the faults and failures of systems as we go along. Now, as far as for on a basic level, what we try to do is we strive to observe the four golden signals of that have been defined from Google, right? I/O rate, so on and so forth, errors, saturation. The stack, the Grafana stack, is typically used for production environments, and I'm touching on the Grafana stack if no one is aware. K6 is owned by Grafana, so in terms of observability, the Grafana stack is there to help visualize, the metrics that you have, the observations that you have available. And so, again, K6 was recently acquired by Grafana, so we now kind of can refer to as Grafana K6. But K6 is typically used in a pre-production environment, generating virtual users to interact with systems that are being observed to detect issues, regressions, and any of the four golden signals before we actually do new releases that face real users in production. Right. So a combination of the K6 plus the Grafana stack plus all the other experimentation that goes on, right, will help achieve some of the discoveries that we have. So if you're not familiar with load testing, we can touch on that a little bit. This is where K6 will come in. K6 is a modern open source load testing tool. It lets you easily create realistic test scenarios under production conditions. Right? It comes from in the form of a cross-platform command line tool, as well as a SaaS platform, allowing you to perform different load tests from either your work machine or in the cloud. You can write scripts in JavaScript, simulating the behavior of your users, and we'll cover a little bit of this later on. You would configure K6 to produce the traffic that you want, execute, and then K6 really does the rest. If programming isn't your thing, K6 also offers the ability to directly record a session in your browser, automatically converting it into a script that K6 can run. There's also a product called K6 Cloud. And so for those K6 Cloud users, K6 also offers the possibility of using a script generator directly in the browser. It's easy to use, easy to approach, right? But it doesn't compromise on performance or the complexity of the workflows that it supports. It's designed to be easy to easily integrate into a CI/CD pipeline, and you can even find its place in chaos testing strategy. So it's very useful in observability strategy, and integrates particularly well into those approaches. And finally, one of our priorities is to offer a user experience that is intuitive, clear, flexible. Our documentation is we haven't had very many complaints about it, at least. But if you go through our documentation and you do feel like there's some clarification that needs to happen, please let us know for sure. But it should be rich, it should be high quality, and chances are that most of your questions will already be answered there. So otherwise, we also have a very active community. There's a huge K6 and open source community that supports the activities involved. And
hey, Vince, sorry to interrupt.
Oh yeah, for sure.
I mean, your voice is kind of like not stable. Nope. It's low, and then it's very noise.
Okay, let me see if I can.
Yeah.
Does this sound any better? Maybe. I'll keep talking, and then if it doesn't sound any better, let me know. I'll try to adjust the mic a little bit more.
Yeah. So Naveen says the audio is not stereo. It's a kind of mono.
Okay. not sure how I can fix that. But I will continue to talk, and then if
yes,
maybe I'll switch mics. If I might have to switch mics if it continues.
Yeah, it's not like we cannot hear you at all. It's sometimes it's very very low, but then all of a sudden it becomes clear.
Okay.
Just go ahead for now. Yes.
There was an update to the driver that I didn't want to happen. That might have done something funny. So I'm sorry for that.
It's okay. Thank you.
Yes, okay. I think it's and present is better.
It sounds a little bit better. Okay.
Yeah.
Okay. So why K6? So let's talk about K6. When I joined K6, I reached out to the K6 team, particularly because I was intrigued with the promise of K6 and the topic of load testing. The topic of load testing like I said, it has a very there's a good overlap between load testing and chaos engineering. It's developer and friendly and tester friendly, right? So as a tester and as an engineer, teams are relieved to find out that K6 is written in JavaScript because it is a language that folks have already learned because of other popular testing tools like Selenium or Puppeteer or Cypress. For most developers, JavaScript is a pretty ubiquitous tool. It is a pretty ubiquitous language, and the entire K6 team is made up of engineers. CEO Robin often gets his hands dirty by coding new features himself. So we can, if you have questions, and it's likely that he could even be the one that's answering them. Right? So there's even a K6 VS Code plugin and others script options that are available. It's also performant, and it's always struck me as weird as some of the performance testing tools are huge to install, use, and run. So some of these some of them are also resource intensive, right? And so it is designed with performance in mind. It's easy to scale, and so you can start a test from the cloud or from the UI, from the cloud UI or from the CLI, and switching between the two is seamless. And we can go over that if we have time later on. You can go from running from one test to another, either on your machine or on the cloud using different geographical locations. Other things about K6 is you can run up to 40,000 users on one load, right? Depending on what you're trying to do and how heavy you're trying to hit it, the K6 should have a pretty good ability to do some of that. K6 does integrate well with a bunch of other tools. I mentioned CI/CD, different APM and notification and alerting, and also has a smaller, similar business model to Grafana, where there is a locally hosted or a locally executed test using K6. So it's also free and open source, and so there is a SaaS platform that's available that adds extra convenience and extra enterprise features, but it is available to you. So touching a little bit, just one slide effectively on what K6 Cloud is. K6 in the cloud. Actually, I can let's go here. This is K6 Cloud. So you can, we'll touch a little bit on this, but the idea is that all of your tests and the results of it are visualized for you, right? So you're able to run different things you can start it from the CLI or you can start it from the UI. It's really up to you. The visualization does help in terms of its usefulness, right? But you can create scripts more intuitively, or you can distribute your tests geographically there. So now we have at least an idea of what K6 is and how it can help in terms of a load testing scenario. Let's take a look at how we can program it to do its job. So the behavior of K6 is fully configurable through advanced systems, advanced options that are available to let you produce complex test strategies. Definable in multiple ways, but the most common way is to do it with a script, as we will see in a little bit. VUs, or virtual users, are the execution units of K6. They simulate a given user. So each VU interprets the execution of a script in a loop, and then in parallel with the other VUs until a final condition is reached. And again, we'll touch on these things, these concepts in a little bit. The number of VUs and their execution strategy is all configured by the user. Each time a script is executed by a virtual user, we speak in an iteration. An iteration provides an additional level of granularity and is also configurable. For example, to interrupt a test after a given number of iterations before. And then during its execution, K6 collects metrics samples that it stores, either in Prometheus or however, some other metric store that you want. These metrics are then used to produce some aggregated results and different reports in different formats that are available to you. So touching on the difference between a request sender and a true load testing tool, a good load testing tool should have features that enable you to fill the room, so to speak. We're trying to generate traffic that replicates user behavior. So we want our folks to be useful, right? So at the very least, as smart as you expect them to be, right? Or the virtual users. So scenarios are different user flows and paths that your system can use. This might involve different requests and might maybe of different types. So if you're testing a feature that requires authentication and maybe quite popular on release, it might be a good idea that you test that whole flow. Thresholds are something sometimes called requirements. And these are the things that build out SLOs, right? They are effectively a boundary that you're trying to test against. And we should also be able to test specific data, right? So that you're not passing the same static value and same static parameters as your request for every request, right? So sending random values from a CSV or even bogus data, right? Can help you with that. If you want to get K6 to kind of play around with it, GitHub/Grafana/K6. The installation instructions are there. There's also a binary that you can just download that's available to you. So into the scripting stuff. This is a simple script, right? This is the most basic minimalist K6 script you could probably have. So after installing K6, you can copy this code, save it to a JavaScript file, and run it as your first load test from your own laptop or from your own computer. This script involves importing the K6 HTTP library and then defines a single function that includes an HTTP GET request from the URL for this URL. So in this case, test.k6.io. It is also possible for users to use other third-party libraries if you so needed to. We won't get too deep into that, but it's just know that it's available to you. So when we run that specific simple script, we get the following result. And because we didn't even define anything special, right? No execution options or anything like that, K6 simulates a user executing one iteration of our script for any given duration. These results in themselves are not revealing, but they allow us to notice that K6 collects data, right, and metrics and generates a load testing report. So we find information on performance of this test, in the form of statistics attached to specific metrics. So we could see here that on average, a request to that test.k6.io took 118 milliseconds. And there were no HTTP errors. And that K6 was able to perform 1.2 requests per second. Right, so there's these different metrics that are available just off the basic. So a more realistic example here, we are testing e-commerce.test.k6.io. This is a real site. It's really available to you if you want to go and try to play around with it. This endpoint is available to you. Here we make a request against it's totally fictitious. You're not really buying anything when you go through. But yeah, there's test data here. Here we define a different array containing the names of a product. Right. Later in the context of our main function, we select a member of this array randomly to perform a query, and then note that we can set this data dynamically. Maybe get it from a file, for example. Then there's an init context where another important difference from the minimalist script that was defined is that we define our array outside of the context of the script of the actual test function. So in doing so, the array of the product is defined and evaluated just once during the entire execution of the K6 script. There's the check section where here you probably notice that we also define checks where they act like assertions, except that it doesn't halt the execution on a failure. It just takes note of the state, the stock, and then reports on the results later on. And then there's the sleep. In order to simulate the behavior of the user, we use this sleep function to add a little bit more variance into the script. We use, I'm just reading through the chat here, catching up. Thank you for the explanations of SLIs, SLOs, and so and all that. Definitely useful. I will remember to add that into the slides for the next time. Can we use K6 to test TIDB? As long as it's an endpoint, as long as it's a network endpoint that's reachable from wherever you're running your K6 script from, short answer is yes. Right? There's different. We'd probably need to look at how, what type of requests and what type of load your TIDB is handling, what type of transactions that it's doing. Then we can try to mimic and simulate that from different users. But yeah, we probably have to look at that. SLOs to measure an application good or not, did reliable, effective, or slow. Yes, that's true. And then K6 only can be used from this example. Yes, K6 is only used to work. In this example, we're only using as an HTTP endpoint. But if it's not a standard HTTP endpoint, it is still and it's still reachable. We can customize a type of load generation for that. I will touch on K6 options from touched on them earlier. Here's an example of one where we define two scenarios with different scheduling strategies. Right? And so one of them defines stages, which tells K6 to adjust its number of VUs accordingly. And then we also define thresholds, which defines our expectations in terms of observed performance. Right? So here our scenarios define their own number of VUs, iterations, and timing. Actually, in here, there's even a plugin for chaos here. There's a K6 chaos extension that does very limited chaos type things, but it is totally you can break things in a limited fashion with just your standard K6. It's nowhere near the capabilities of chaos mesh, but yeah, at least it's available. All right, so on to the fun part in terms of the demo. I will see if I can. What I'm going to do, let's start here. So this is the online boutique. I don't know if any of you are familiar with this project. It is a Google Cloud project, but it is effectively a microservices demo application. All of this is, if you walk, you can click through, you can add things to the cart, place an order, continue shopping. There's a currency conversion up on the top. All of these are different microservices that are available, right? And you click in on the product. You can see that there's this advertisement, right? And there's different suggestions for recommendations, right? So it's a pretty useful demo application, especially for trying to demonstrate breaking things, really. So this is my demo application. I also have a Grafana dashboard that measures some of the response times and has a bunch of metrics that are from there. There's also this Kubernetes integration that most teams have found useful, right, in terms of just seeing some of the metrics that are available to them, right? So you can see just at a glance that there are some things that there's metrics that we can just be aware of, right? So from here, just know that this is available. Again, this is what's going on. This is just an example of what the simple script was, right? Just going to k6.io. Let's clear this. And so here, to run a k6 script, this is a simple script.js. All we're doing is k6 run demo script.js. And so here we start to see some of the output that's there, some of the initial instructions, right? Here it's trying to do 20 VUs for 2 minutes and 30 seconds over 3 stages, right? And then as you're running things, you can see that there's, if you're thinking, well, wait, I didn't really want to do this, it is totally like escapable, right? Control C does stop it. And then when you do stop it, it will actually give you some of the metrics that it tried to find in the beginning. Right. Oh, I was running demo script. I should have run simple script. That's what I was trying to do. Going into demo script. Now this is a much more complex script that's going on. That's actually testing my online boutique here, right? So this looks more complicated, but I coded none of this. This is actually done available through K6 browser plugin that will record everything that I'm doing. Right? So I went through and I added pretty much what I just demoed to you earlier. I added something to some sunglasses and I placed the order. And then I continued shopping, and then I went to and I added maybe a tank top, right? And I changed the currency, and then I placed the order, right? So different things that I tried to just pretend to be a user, right? So here, if we walk through this script just a little bit, here I am choosing a specific location and the distribution from that location. So all of my users, all of my virtual users are coming from Ashburn out of the Amazon data center that's there, right? I'm having 100% of that. If I wanted to, I could choose maybe maybe I have a split of users between US East and somewhere in Europe, right? And I wanted it to be a 30-70 split. I could do that here if I wanted to. But for this example, it's really just 100% of users strictly from Ashburn. Here's some thresholds that I've defined, right? And what I'm hoping for is that I want my if something breaks, my errors should be less than 2%. Okay? And then I want my request duration to be at least 95% of them, for my P95 to be below 2 seconds. Right. And if it's not, all these are just thresholds. This doesn't define any sort of failure criteria. It's just letting you know that if if something happens, it's hit these thresholds. You can set it so that if it hits thresholds to stop the script and stop the load test, but that's not being set here. And then here's where we start to build a scenario where during the first 15 seconds, we will climb to 20, right? And then we'll try to run for, stay at 20 VUs, virtual users, for 2 minutes, and then ramp down to 0 over the next 15 seconds after that. Here's where if we're trying to execute scenario 1. And so this is scenario 1 where I will load the first page. And then my second step is to load a specific product, right? And then my third step is to add it to the cart, right? And then check out. And then, and these are the different values, right, that are involved in the checkout process, right? So it's passing those along, and then just repeats, right, for different flows, right, that are available, right? So this is the simple one. There's an extended one that I have that we can add even more, but as it becomes as simple or as complicated as you want it to be, right? So again, I coded none of this. This was all just generated from clicking around, and there is a K6 browser plugin that you can use to actually generate that. Embedding chaos mesh in K6. So there's we're hoping that we can do that. This is I'm reading from the chat. I'm hoping that we'll be able to embed chaos mesh functionality into K6. We would need to develop an extension, a K6 extension, to be able to do that. But otherwise, between the two, I believe that at the very least you can coordinate, and I can try to do this here in this demo. We can try to coordinate the chaos mesh UI and along with the script, right, that we can kind of kick off here. But for the time being, they are not, unless you manually build the code yourself, maybe an API, a set of API requests or something like that, right? But unless you do that, then there's no other functionality between the two just yet, but soon. All right. So I will kick this off. And again, this is my demo script, right? So A6 run demo script. Okay. So again, here we go. This is 2 minutes and 30 seconds over 3 stages, and this is all defined back here, right, where we've defined 15 seconds plus 2 minutes plus another 15 seconds, so a total of 2 minutes and 30 seconds, right? And if we need to stop, we will stop gracefully at over 30 seconds. And here we're looping 20 VUs, right? And so again, as we're building all of this, we're seeing that we're starting to send, or we're hoping that we're starting to send some traffic, and we can start to look. Here's where I accidentally started a little bit earlier ago, right? I'm measuring over the last 15 minutes, but here we can start to see that there's some sort of load coming in, right? Now, how is the rest of my application handling, right? So even if I'm sending virtual users there, I see that my latency here has climbed up to, at the very least, for any particular endpoint, maybe 500 milliseconds, right? One thing that I've noticed just so far, just from doing this, is that here I started 7:32 my local time, ended 7:33, right? This is about a minute, less than that, right? This latency spike is much longer than a minute, right? So there's some sort of application thing that I need to figure out, right? Why is it doing that? Maybe it's an application, maybe it's an infrastructure thing, I'm not sure. But I do need to figure that out. And so here we can also see whether or not any of the containers needed to be restarted or anything like that. But we see some performance things, right, out of this. And this is without any sort of targeted chaos engineering experimentation going on, right? This is just overall what is happening to my system, right? So I can start to see that there's some things that I should probably try to target, right? How well is my application actually handling things from a latency perspective, from a response code? Like, am I okay so far doing 2,000 requests per second, right? That type of thing. Am I okay handling 66 successful orders placed per minute, right? So there's different metrics that are available. And then diving into the actual Kubernetes side of things, here we start to see some CPU usage that's kicking up. It doesn't look like my memory has spiked any at all, right? So things here that are available to you. Here we see after the script is finished, has completed, we can start to see that my request failed. I had none. My duration was way under my threshold. So all in all, this could be considered successful, right? And then if we want to go a little further, we can maybe 40. So here I'm ramping from 40 over 15 seconds. Maybe let's just do this for a minute, right? And then drop down. So I'll save that. Run it again. Here we see that this is now 40. It's now just for a minute and 30 seconds, right? So we'll see maybe a specific spike. And maybe while I'm running this, during that first 15 seconds. So I should be, since I'm now past the 15 seconds, I should have reached my 40 to use. Let's jump in and I've set up a pod failure, right? Specifically for my front end, maybe for 15 seconds. And again, specifically for my front end. I submit that and let that run. Oh, like that. Oh, there it goes. Oh, and here we saw there's a bunch of errors that just kicked in. Right. So obviously I only have one. I only have one. I only had one running. And I just killed it. So obviously I expected there's going to be something broken, right? And so what are the types of errors that I'm seeing, right? So maybe I could come in, see if it's still running. Might have come back up already. But here we see now that some of the thresholds failed, right? So as you kick in chaos, as you kick in experiments that are for trying to discover some of these different failures and different responses and things like that, the metrics come back, right, and tell you, well, over the past minute and a half, 7% of them failed, right, depending on how you coordinate your experiments along with your load testing. But all in all, what this does is, yes, I am a big proponent of doing chaos engineering and performing experiments in production, but not everybody has that flexibility or capability to do so, right? So introducing load testing and introducing your failures and your experimentation more left, right, earlier in the development lifecycle, you'll be able to catch a lot more things without them costing so much, right? Without actually having to say, hey, we can do this in production. You can actually do a lot of your discovery much earlier than that, right? So where it becomes much cheaper, much easier to implement fixes, to implement changes, and things of that sort. Any questions?
Hi, Vince. Could you hear me?
Yes.
I'm Zhixiang, and I have a question about K6.
Sure.
But it's not related to the just demo and your presentation. My question is, I noticed that K6 is using scripting instead of the configuration file, and in the last years, I always use Apache JMeter as load testing tools, and I am not familiar with K6. It seems using script. It seems using a scripting pattern is much convenient and efficient to define the load testing scenario. But it seems it's hard to create a script rather than using a configuration file. It occurs the user must know little knowledge about the JavaScript. And actually, the Chaos Mesh is the Chaos Mesh team is considering develop some Chaos SDK and maybe some library for inject chaos in application or process level. So but it's a very early idea. So I want would you like to share something about the scripting part or the
so as far as scripting is concerned, you don't need to know. I know nothing about JavaScript. I am not a JavaScript programmer at all. So what's really cool is that there is, and I'll just touch on this from here. So if I want to create a new test, right, there's this test builder or a script editor. So if I knew how to code in JavaScript, I could start here, right? But this test builder here has this recording a scenario function, right? So what I can do is I would record, and let's just start from scratch here. I'll take my IP and
just you mentioned that the browser extension.
Yeah. So here I can start recording, and this is if I want to start right away, I can, right? But this is just telling you what it's going to do, right? So I could start recording right away. So here it's starting up and it's going to my endpoint. I want to add loafers. I want 2 of them. Add to cart, and I want to change to British pounds. Then I see that and I'm waiting a few seconds. I'll place my order. Right, that's it. When I'm done, I'll hit cancel. So it recorded all of that for me, right? And so now here I have this. If I want to add a few other things into there, maybe I want to measure all of the different static assets that are there. I don't want to do that because there's a lot, right? But if you wanted to do that, you could. Here's an option to generate sleeps for anything more than 500 milliseconds. I don't want to automatically generate them or automatically change it, but then this tells you like, oh, it's you're checking your Google APIs and GStatic and Bootstrap CDN. If you want to include that, you can, right? But I will just save this, and so now here it's going through all of the different pages that it's trying to load. But now I see the script. Right, and so it scripted all of that for me.
Wow, that's amazing. Yeah, K6 has.
Right, and then I can run it. I can run it straight from here, or I can just copy this. Right, copy this. I can dump it into here.
Wait, run that in your browser?
Yes, so I could because I'm in K6 Cloud. In K6 Cloud, I would be able to run this in my browser, and if I wanted to change it a little bit, I could. Right, so by default, it sets this to 3 minutes. Let's see, I just wanted to do this for. Oh, I can't edit this. This because it's in the script. But if I wanted to do this, paste that into here. Let's change this to 1 and 15 seconds.
Yeah.
Right. So now that I'm here. K6 run ad hoc. Oops.
Yeah.
Right. So this will run it here locally. Again, if I wanted to visualize this, I'm going to stop this. If I wanted to visualize this in cloud, K6 Cloud, that script name. Right? And so now it's uploaded, and I have my there's some other credential verification happening in the background, right? But here it's trying to run everything and get everything going in the cloud. Right? And so if I went to K6 Cloud and I looked at my tests, not sure where it actually set it, because I don't have, there's one thing that's missing out of there, and that's some other verification settings.
Ad hoc.
So send it. But anyways, the goal is, the eventual result would be something like this, right? Where you start to see some of the outputs from that, right? And that it's available to you.
Yeah. I got it. Yeah. It's very convenient, and
for sure.
Yeah, it gives me a picture about K6 and the K6 Cloud. It is definitely helpful to help us about the design. Maybe the future Chaos SDK. Yeah, for sure. Very thanks.
Cool. So so if you have any other questions, you can go straight to the GitHub and repo that's there. There's a community. There's also a Slack community Slack, right? So feel free to hop in, say hi, ask questions. Again, the K6 team is relatively small. We're like 50-ish folks right now. So more than likely there will be there's a huge community behind it, and it's very likely if you have any questions, they will get answered thoroughly.
Great. Thanks, Vince. This is really great sharing, and I really learned a lot about load testing and the K6 here. Yeah. Okay. I think just heads up. Maybe today's meeting is a little bit longer than usual, but I think it's worth the time. Next up, we have our ChaosMesh contributor, Chenxi Li, who will give us a technical update for the ChaosMesh project. It includes some updates on the ChaosMesh release cycles and the recent releases, release plans, and also he will also do a demo for the progress with ChaosMesh workflows. Okay, Chenxi, would you please share your desktop and start sharing? Yes.
Okay. Can you hear me?
Yes.
Could I share my screen?
Yeah, you can share your screen.
Oh. Can you see my screen?
Yeah.
Yes.
Okay. Let's start. Okay, hi everyone. I'm Chenxi, and I'm glad to share technical updates in the last month. There are many exciting features in the last month. Let's take a look at ChaosMesh first. And the first one, we add more status for the records of experiments. Previously, records could only show the final state of experiment. So we add the injected count and the recover count fields in the status to indicate how many times the experiment is injected or recovered. Yes. And the second, we add the ARM architecture 64 support for timecalls, which means you can use timecalls on your ARM architecture 64 machine after this commit. We will add ARM architecture 64 support for IO calls by the same solution later to empower ChaosMesh to completely support the ARM architecture 64. Yes. And next, we add a comment to grab size of memory stress in the dashboard. So that users can easily know they can set the size to a percentage, not only the fixed size. Yes, and next we implement a brand new user interface for the workflow dashboard. It's very cool, and let me show you the usage. Yes, this is built from the master branch and deploy on my machine. We first enable the next generation of workflow interface and then enter the workflow. First, we can create a new workflow. Then you can see we just dragged a serial node and named it serial 1 and have a 1 hour deadline. Then we can add more experiments into the serial node. For example, the HTTP calls set the abort and set the target to request. If namespace selectors, we select the pod, Nginx pod, and give it a name. And with deadline 5 minutes. Yes. Then we create a HTTP calls node, HTTP calls experiment. And then we can also add more experiments like a pod kill. Action is pod kill and select the pod, give the name with pod kill example. So now we create another experiment and we can link them by the line. You can see. Now let's submit workflow and have a preview. It generates the YAML of workflow and it has two child entries like the HTTP test and pod kill example. Yes, it's still working in progress, but we will bring it in the future. And next, let's look at the CalSD. We also introduced many new features for CalSD in the last month. And the first one is the Redis tag, which empower users to expire Redis keys, to modify memory limitation, and to penetrate memory and to stop or restart server as a sentinel. And next, we support the Kafka tag, which empower users to fill specific topics to fraud the Kafka server and to make the data directory unreadable or unwritable. And next, we support the VM, a virtual machine attack, based on the version, which empower users to destroy target virtual machine. And finally, we support user-defined attack, which empower users to customize attacks with an attack command and a recover command. Yes. Next, let's see the new release. I'm excited to announce that version 2.2.0 was released in the last month. As all the features has been introduced before, I think it's unnecessary to explain more. You are recommended to upgrade if you require features it carried. Now we can look at the features and we can refer to the release note for more details. Yes. And then let's talk about the common patch. There are several bug fixes after version 2.2.0 release. We can look for them. As the next patch version is 2.2.1. Yes, this is some unreleased patch. And next, let's introduce the release cycle. Yeah, if the release cycle is about the minor version, the next minor version is the 2.3.0. The detailed introduction can be found on my website. I only talk about the main points today. After last minor version, the 2.2.0, we plan to reduce the release cycle to 2 months or 8 weeks. During the first week, Mesh committers and maintainers would nominate new release managers, and they will be selected by pool finally. As release managers in the current release cycle, we must decide the features should be queried in the version 2.3.0 before the 11th July and start freeze all unmerged features. Then we must cut a new branch in the 7th week and read the minor version in the final week. And as a normal developers, the only thing you need to notice is the unmerged features will be passed to the next release cycle in the final 3 weeks, which means until the sixth week, all unmerged features will be passed to the next release cycle. Yes, and this is the release managers in this cycle. And next, as the release managers, we must keep a release checking of the next minor version. Here is the checking issue of the version 2.3.0, which listed the expected features carried in this release. We can see the first feature is the new UI for workflow on dashboard. We are still working in progress for it. Please keep hopeful with such core feature. And the next is the TLS support for HTTP calls. This feature is already implemented in our CalcTproxy repository, but we still need some time to use it in Mesh. And the next is the disk calls, which should be implemented, but we need much time to review the large changes of source code. And the next is the block calls, which is known as the calls driver, a tool to schedule the I/O by the I/O emulator or IOEM. And we need time to fix some known bugs and review the source code. And the next is the enhancement of JVM calls, which empower JVM calls to inject force into MySQL client. This pull request is accepted and merged already. And the next is the multi-version API, which enable us to make breaking changes into API without upgrading major version of Mesh. We also need time to review the changes. And the final is the graceful start. All experiments can keep their effects after restarting or upgrading components of Mesh with this feature. We are still doing some pre-positive works, so this feature may be passed to next release cycle. Yes. And finally, I will introduce the idea about chaos fusing. Chaos fuzing is not an official announcement or plan, which we are just discussing about my proposal. Yes.
Hi, Chenxi. Since it's just a proposal, for now, we can maybe save it for next community sharing.
Okay,
yeah.
all right.
Yeah, people can come to this proposal to join the discussion if they're interested.
Yes, if someone is interested in this proposal, you can comment under the discussion or our channel. Yes. All right.
Thanks.
Thank you.
Okay, that's all your sharing, Chenxi.
That's all. Yes. Thank you very much.
Great.
Hey, Kevin, do you announce our new committer?
Yeah, actually, in the self-introduction part, I already kind of announced our new committer, Xiangling.
Oh, okay.
Yeah. So because of the, sorry, let me quickly share my desktop. Because of the time limit for today's meeting, I will not go through my slides one by one. And people, if you are interested, you can just go through the slides. There are just some resources listed for KubeCon, and already introduced Xiangling as our new committer. Thanks again and congratulations. And here are some governance updates. You can check out the
Hello, Kevin. Hello. Oh, maybe. Oh, hello, Kevin. I can't hear your sound, your voice.
Maybe there is a internet issue.
Oh, maybe Kevin's network is unstable. We can't hear his voice.
Yeah, I cannot either.
Yeah, but it's a little weird. We could see his screen smoothly, but we could not hear his voice.
Hello, Kevin.
Yeah, that's awkward.
Yeah. Oh, maybe Kevin also have some other sentence or other words to other updates to our community. Yeah. Okay. Maybe maybe we can close this community meetings, and if we ignore something, we will update in next month. And thanks for joining this meeting.
I'm back.
Oh,
Sorry. Sorry, I don't know.
Yeah, we can close. We can end our this meeting.
Yes. Actually, we can. We definitely can conclude this meeting. That's. I have shared everything that I want to say. Just want to thank everybody for attending this meeting, and we will upload the recording very soon to YouTube. And also, if you haven't joined our Slack yet, just feel free to join and discuss your chaos mesh experience with us. Okay, that's all for today's meeting. Again, thanks.